plan is to do both 4C.1 and some of 4C.2, and then in our lesson on Tuesday we'll make our way through 4C.3. So we're sort of getting 4C all done over 2 lessons, so we'll see how we go. So we have had a bit of exposure to it last year. We just introduced you to the idea and to finding complex numbers in polar form. I can show you the video from last year, but I filmed it last year. Okay, so we've got what it is. Okay, the C is for cos theta, the I is for imaginary number, and the S is for sine theta. And if we think of a complex number on the Argon plane, we have the real axes and we have the imaginary axes. And if we have some complex number Z, it is composed of, it has a real component and an imaginary component. And we can represent it in terms of cos of the angle that the complex number makes with the real axis. Okay, so for 3, all right, the way we express a complex number is firstly, what is the modulus of it? If we consider this number here, the modulus of 3, the length of it is going to be 3. And our angle, I'll show you how I'm thinking about this. The number 3 is from 0 to 3. All right, that's the complex number 3. It has no imaginary component, and so our angle is 0. All right, so a bit redundant to express it as in polar form. Okay. In B, all right, we've got minus 2i. So again, consider our Argon diagram. That's going straight down the imaginary axis 2 units. Now the modulus always has to be positive. So it's going to be 2 cis, and our angle, okay, there's 2 ways we could write it. Minus pi on 2. Okay, we've gone pi on 2 units back this way. Or you could express it as positive 3 pi on 2. But generally, you will have some solutions outside of it, but generally we do try and express angles between minus pi and positive pi. Okay? So we've got 2 cis and negative pi on 2. We have 3 plus 3i. So here we're going to need to find both the modulus and the argument. Okay, so if I'm going to find the modulus of that, if this is, let's define it. Okay, if this is z, then the modulus of z is going to be the square root of 3 squared plus 3 squared. Okay, the square of the real component plus the imaginary component. We'll simplify this. Okay, so we're recapping a few survival now. 3 root 2 is the modulus. And by this stage, we should be getting fairly comfortable with angles, right? If we think about that, if we're going across 3 and up 3, that angle is going to be a 45 degrees, pi on 4. So that means in polar form, we're going to have 3 root 2 cis of pi on 4. Cool. Okay, and you could write root 18, doesn't matter. Okay, root 18, 3 root 2, that's the same. Okay, on to question 2. Given z equals the square root of 2 cis of pi on 3, part A, state the modulus and argument. Okay, so the modulus of z is the square root of 2. The argument of z is going to be pi on 3. Part B, sketch on the Argon plane. So on the Argon plane, we have the real axes, the imaginary axes. We have a modulus of root 2 and an angle of pi on 3. Pi on 3 is more like that. Alright, so that would be a good way for us to sketch it on the Argon plane. And then part C, find it in Cartesian form without technology. So Cartesian form, that means it wants us to convert it back to a coordinate. Alright? So if we consider this complex number, root 2, so z is equal to root 2 times cis of pi on 3. Oh, let's write out the whole thing. Cis of pi on 3, which is root 2 of positive pi on 3 plus I sine of pi is by definition. Alright. Then we will use our unit circle to establish the values for cos of pi on 3. So at pi on 3, cos is half. So we have root 2 times half plus I times sine is root 3 on 2. And now we will distribute the root 2. Just go root 6 on 2i. Okay. Cool. Let's have a go at C.1, and we'll come back a bit later, go through some C.2.